Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And this short video is going to try to demystify the logic associated with a hypothesis test. Okay. And maybe just to get started, I have two distributions here, okay? But let's just concentrate on the red distribution for a moment, okay? I have a particular population, okay? There's 45 people in the population, okay? So n is equal to 45, okay? That's the size of my population, okay? And what I'm going to assume is that the population has this particular characteristic or this particular distribution associated with it, where we're representing the distribution as a histogram. Okay, so what I'm saying is 5 of the 45 people in the population have a value between 30 and 40. Let's say this particular experiment has got to do with how much a particular student has spent over the past week. So out of the 45 people in my population, 5 students spent between 30 and 40, 10 students spent between 40 and 50, 15 students between 50 and 60, 10 students between 60 and 70, and 5 students between 70 and 80. Okay. Now I've set this up in a way that our distribution is symmetrical. Okay, because it's a symmetrical distribution or symmetrical population, what we know is that the mean of this particular distribution is down the center. So for this particular population, the mean is equal to 55. So the average spend of these 45 students out of this particular population is 55 euros. In this particular distribution scenario over here, we've still got 45 people in the population, but let's say for argument's sake that 5 spent between 10 and 20 euros, 10 spent between 20 and 30, 15 spent between 30 and 40, 10 between 40 and 50, and 5 between 50 and 60. So we still have 45 people in the population, but this distribution is now centered on 35. So the population mean is 35. Okay. Now, let's just assume that this is our population over here. Okay. So we're assuming this is the population, yeah, in the first instance. And let's just work out some probabilities. Okay. Well, let's actually work out all the probabilities first of all over here, yeah. Okay. So the probability, if I randomly select a single person from this particular population, okay, the probability that the person spends between, let's say, the probability that the person spends between 30 and 40 euros, okay, the probability would be equal to the number of favourable outcomes divided by the number of possible outcomes. Well, there was 5 people that spent between 30 and 40 out of a possible of 45, so the probability would be 5 over 45, which gives us a value of 0.11. Okay. I'm wondering what's the probability that that person selected spent between 40 and 50 euros. Well, the probability would be the probability that they spent between 40 and 50 euros would be equal to 10 chances out of 45, so it'll be 10 over 45, which is 0.22. Okay. Continuing in this fashion, the probability that the person spent between 50 and 60 euros would be 15 out of 45, or 0.33. The probability that they spent between 60 and 70 euros, 60 and 70 euros, would be equal to 10 out of 45, which is 0.22. And the probability that they spent between 70 and 80 euros, the probability that they spent between 70 and 80 euros, would be equal to 5 over 45, which is 0.11. Okay, so these are all the probabilities associated with the red distribution if I was to randomly select a single person from the 45 people. Okay. So let me maybe just label these here, or maybe just circle these here in red to say that these are the probabilities associated with the red distribution. Now, with respect to the green distribution, if I was to randomly select a person from the green distribution, the probability that they spent between 50 and 60 euros, okay, here's the probability between 50 and 60, would be 5 chances out of 45, or 0.11. The probability that he spent between 40 and 50 euros would be 10 chances out of 45, or 10 over 45, which would be 0.22. The probability that we selected somebody from the green distribution and that they spent between 30 and 40 euros would be 15 chances out of 45, which gives us a value of 0.33. Okay, and so on and so forth. Okay, so here's our two distributions. Okay, and each distribution has different probabilities associated with it depending on where the distribution is centered. For example, if I was to select if the distribution was centered on 55 with these particular characteristics, and if I was to randomly select from that particular distribution, the probability of us selecting somebody that spent between 30 and 40 euros would be 0.11, a small probability. If the distribution was centered on 35, the probability of me selecting somebody at random and them having spent between 30 and 40 euros would be 0.33. Okay, and this is the crux of it. Okay, it's the crux of a hypothesis test. Okay, is with a hypothesis test we have two positions. We have what's known as the null position. Okay, let me maybe just write that down. Okay, with respect to a hypothesis test, we have a hypothesis. Okay, and the hypothesis has two positions. We have the null position symbolized by H0, and we have the alternative position symbolized by HA. Okay, and the null position is something that we assume to be true. Okay, so in this particular situation, if I assume that the population that I'm selecting from has an average value or a mean value of 55, okay, so what I'm going to assume is that the population has a value of 55, okay, that's the null position. The alternative position would be that the population doesn't have a value of 55, okay. So if I assume that the population has a value of 55, okay, and if I randomly select from that particular population, okay, so if we randomly select, okay, from the population, and if we observe, okay, let's say, if we observe that we randomly selected somebody that spent between 30 and 40 euros, okay, so we're assuming that's positioned on 55. We randomly select from the population, and the person that we've selected is a person that's spent between 30 and 40 euros. Okay, so if we randomly select and if we observe, yeah, that the person spent between, let's say, 40 and 30 euros. Well, the probability of us observing that particular value, okay, that this person spent between 30 and 40 euros, okay, would be very, very small, okay, if this was true. If true, okay. Now, so really what we're saying is, if the population's distribution is truly centered on 55, okay, the probability of us observing somebody that spent between 30 and 40 euros, okay, would be very, very small. Okay, that's if this was true. Okay, now if this is not true, okay, in other words, if the mean is not positioned on 55, and let's say the mean is positioned on 35, okay, well, the probability of us randomly selecting someone from the population, yeah, and them having spent between 30 and 40 euros would be pretty high, okay? And this is the logic of a hypothesis test, okay? And what a hypothesis test allows us to do is it allows us to hypothesize about the position of a particular distribution, okay, its center value, okay? Allows us to hypothesize about the position of a distribution. Then we go off and we conduct an experiment. And if what we observe is very, very small, okay, or unlikely, okay, well then what we say is, we say that there's evidence to suggest that this is not the case, okay, simply because there's more of a possibility, yeah, okay, that the probability distribution or the distribution associated with our population is centered between 30 and 40, if that makes sense, okay. So really what we're saying is this, is that the probability of things happening in the tails, yeah, are very, very small, okay, if the distribution, okay, is centered on 55, okay. So if the probability of observing something in here is small, if this is true, okay, well, the probability of us observing something in here, okay, would be large if the distribution wasn't centered on 55 and was actually centered around 30 to 40, okay. Now, what we do is we randomly select from our populations, okay, and the random selection, okay, through random selection, okay, what we'd more than likely see happening, yeah, if this was the case, okay, if we were to randomly select from this particular population here, okay, well, what would more than likely happen is that as I randomly select, I would more than likely observe people between 50 and 60 or between 40 and 70 rather than observing somebody between 30 and 40, simply because there's more people in this particular area of the curve. Okay? That's if the mean was positioned on 55. Okay? Now, if I observe something that's in the tail, okay, something that has a very, very small probability, okay, well, what we're really saying is this, is that through random selection, okay, we'd more than likely see something like this through random selection, and its probability should be relatively high. So this is evidence to suggest that our distribution isn't centered on 55 and more than likely is centered on a different value that would give us a higher probability for what we've observed. And this is the crux or the logic behind our hypothesis test. Okay, our hypothesis test once again has two positions. Okay, it has a null position. In this case, I'm assuming that the population from which I'm randomly selecting from has a mean value of 55. If this was the case, well then when I randomly select from the population, okay, I wouldn't expect to find a value between 30 and 40. I'd more than likely expect to find a value between 40 and 70, okay, if this was true, okay. Whereas on the other hand, okay, if I do randomly select from the population and I find someone between 30 and 40, okay, we more than likely have a distribution, okay, that's centered on 35, okay, which is evidence to suggest that our hypothesis that the distribution was centered on 55 is actually incorrect. Okay, and this is where our test statistic comes into play. Okay, our test statistic, and let's just assume that we're dealing with a t-test. Okay, so if we're dealing with a t-test, our test statistic, okay, our test statistic is t is equal to x bar minus mu over s over the square root of n. Okay. So what's happening with the test statistic is this, is that we have a particular hypothesized position of our distribution that we hypothesize through our null hypothesis. We go off and we capture a piece of evidence, our x bar, our sample evidence, and we calculate the distance between our sample and our hypothesized center of our distribution. Okay? So the further this sample is away from our hypothesized center, don't forget, when we take two numbers away from each other, we're calculating the distance between them. So the numerator in the t-statistic is telling us how far our evidence is away from our hypothesized center of our distribution. So the larger this value is, okay, the more likely that our evidence falls into one of our tails. And things that happen in the tails have a very, very low probability of occurring, okay, if this is true. Okay. So our test statistic calculates how far our distribution is, our hypothesized distribution is away from our evidence, and it calculates that in standard units. So the larger the test statistic, okay, the more evidence to suggest that we're in the tails of the distribution. Okay, so our distribution has a center value. The larger our test statistic, if our test statistic falls into either one of these regions here, Okay, we say that there's sufficient evidence to suggest that our distribution is not centered on this particular value, okay, or not centered on the hypothesized center of our population. Okay. So, guys, I don't know whether that was helpful. Hopefully, that helped to demystify the logic of a hypothesis test. The next video is going to do a hypothesis test. It's going to do a single sample test. So, once again, thanks for your time. This was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland.